Okay, this video is to support activity 1.2.4 tolerance analysis in your MyPLTW textbook for Principles of Engineering. And so we're talking about tolerances and how big can certain objects be or tolerances be. And ultimately, you're going to put this into test in your shoe design that you have come up with. And so I've already kind of given you some stuff. So attached to our Google Classroom assignment, you have this spreadsheet that has what we're going to work through. I'm going to show you all the formulas and everything that we're going to work with through to get the not the example battery width using tolerances. And so we'll talk about the battery width tolerances. Then essentially the steps that I give you or we work through here, you're going to practice with the height of the battery using the given data that you've got, as well as the length of the battery using the given data that you've got. And ultimately, you're going to put that into action with your shoe sole that you've created. Now, you're going to replace this multi-view diagram with your shoe's multi-view diagram. So this right here, you're going to take out, replace it with your shoe diagram. Then using these values, plugging in the height of your outsole, you're going to create your own tolerance loop. So you're going to work through to create a tolerance loop. So these two are practice. This one you're putting it into action with your shoe. So let's go back and we'll look at this. So this is our example that we're going to work through, which is we're going to look at the width of the battery. Now, I've put all this information together, but everything is coming directly from the MyPLTW curriculum. So that if you've got this activity 1.2.4, you can see everything here. And so what we're looking at is how we're going to figure out what's known as a bilateral tolerance. So right here, we look at this, and if we click through these, we go through all of the information for our battery width. So these are all of the known and unknown things that we have for our creating the battery width. And so what we've got here, so like take for example, we've got this wall thickness. This wall thickness is 0.5 millimeter. Now this plus minus says it has a bilateral tolerance, which means it can go either way. So it could go to 0 or to 1. So that could be the thickness of our wall. Just like with our logic board here, the logic board is 21.2 millimeters plus or minus 0.5. So it can get all the way up to 21.7 or all the way down to 20.7. So what we're going to do is we're looking at, or 20.7. So what we're going to look at is how do we create this battery width? And so what are we trying to do? So what we're trying to do is we're trying to solve for the width of the battery. And so we've got everything here. And so this has given us all of our data. Now what I've done here, if we go back in here, is I've already plugged all these values in for you. But if you want to see them, you can expand out your diagram here and you've got all the information here. So I've got everything that I've got known. So I've got my safety air gap, the nominal width, which is what's the width it was designed to be, and what's the tolerance. And so we're not doing the plus or minus, we're just saying the tolerance is at that point too. Okay, and so then we've got all of our information we've got. Now what we don't have is we don't have our battery width. That's what we're trying to solve for. That's this question mark here. And so we're going to figure out what is the root sum squared max width, what is the worst case width that we can have, and what is our percentage of difference. And so those are the formulas that we're trying to figure out. So when we go back into this activity here and we look at this, the first thing that we've got is to calculate the nominal width for the battery. And we've got our formula right here to calculate the nominal width is the sum of all of the nominal values in the tolerance loop. Okay, the dimension of every value if it could be manufactured perfectly. So that's going to be our nominal width. We're just adding up all of the dimensions. So when we go back to this, we're going to first figure out what is our nominal battery width. Now, one of the things that you'll notice in here is that we have one number that is a negative. And in everything, you're going to have a negative value in there because that's going to be kind of, essentially, in this case, that's our overall housing width. So what we're saying is the total width of our battery is 71.5. So everything else within that battery is going to be taking up some kind of space. So what we are doing is we're adding all of our values together and then we're subtracting out the overall width. And I'm going to explain that to you more when we get to our second piece, but you have to have 1, 2, maybe 3 things that are a negative value that give you the overall width, depending on how the dimensions are provided to you. So in this case, our total housing width is 71.5. So we're going to add all of these up. So if you look at this, if I add all these up, I'm going to add this value, I'm going to add this value, I'm going to add this value, add this value, add this value, add this value, and then this value is going, this one's going the opposite direction. I'm going to subtract this value. So add everything to the right, subtract to the left. So what we're going to do here for our nominal battery width, we're going to create a formula for it. Now, when you're creating these formulas, it's super important. If you don't have all the same values, you can't just copy and paste the formula. So you're going to follow the process for it. So we're going to hit the equal button. That starts our formula. We're going to type in sum. So we're going to create a sum. What do I want to sum up? It's going to give me a parentheses. I'm going to drag a box around all of the values that I want to sum up. I'm going to close my parentheses and I'm going to hit the enter key. Now, this, we're not going to autofill this in. And so this is going to give us our nominal battery width. Oh, what happened here? It should be, I got here our battery width. This is our nominal battery width. All right. Here it is. Here's our battery width. All right, so now I had an extra value in there. So I'm going to hit my equal sign. I'm going to write my sum in here. Then I'm going to do my parentheses. Now, if I only had 3 values, I would just drag a box around the 3 values. But I'm going to drag a box around all of the values that I have. So that's going to give me all the values that I have. Then I'm going to close that value out. And then I'm going to hit the enter key. And so what I've got here is this is the value of our battery. So our nominal battery width. Now, we don't want it to be a negative value. So there's 2 ways that we can handle this. I can go back up into my sum and I can multiply it by -1 to make sure that I get just a positive number. So I can just add to this formula and just do asterisk times and all times it by -1 to make sure that I give myself a positive number, because the width of something is going to be an actual value. Or we could go back in and change this formula to create an absolute. And I'll show you how to do that. And that's the way I prefer to do it. So again, I'm going to put my formula, I'm going to do an equal sign. And then the first thing I'm going to do is I'm going to type in ABS, which is going to give us absolute value. What that's saying is I don't care if it's negative or positive. I want just the numeric value. So I'm going to hit absolute value. And I'm going to click on this. So I'm going to hit yes, I want the absolute value. Then what I'm going to do is it gives me a parentheses. And just like when you're in math class, if you open a parentheses, you've got to close a parentheses. So we're going to do a sum. So we're going to get the absolute value of a sum. So we're going to type in our sum here. Or I could just add each of these cells up. I could just click to cell, click to plus, click plus, click plus. Then I'm going to select my box around what are the cells that I'm trying to get an absolute value for. I'm going to close that parentheses, and that first parentheses I'm closing is my sum parentheses. Then I have to close the parentheses again for that absolute value. So you'll notice here I've got 1, 2 open parentheses, 1, 2 close parentheses. Then I can hit the enter key, and I've got my value of 36. So my nominal battery width is going to be 38 millimeters. So that means if everything is manufactured perfectly, our battery width should be 38 millimeters. So that's if there are no variances for human error, we should get a 38 millimeter battery. Okay. So now we're going to go back to this. And so we've got our nominal battery width, and that's exactly what I would do for everything. So if I go, just give an example, I go over to this one, I'm going to fill in all my values here. So my safety gap, my battery height, I don't know, housing wall, battery adhesive. Now here's going to be my negatives. My negative is going to be this housing height and the screen adhesive, right? So these would be my 2 negative values. So for this one, my housing height would be a -8.2 because we're going to take out the overall housing height. And I'm also going to take out the screen adhesive because that's going to be the total distance that I've got from it. So my screen adhesive is going to be a -0.4. Everything else is going to be a positive number, right? So I would put all the rest of those in along with my tolerances. So my housing height tolerance has got a tolerance of 0.4, and my screen adhesive has got a tolerance of 0.1, and I fill in the rest of the information that I know. Then what I would do here is the exact same thing. I'd create my sum value, adding up the values that I've known, and I've got that first part. So we're going through each of these. So what I do for this one, you're going to process through for all these others. So you're going to practice with all these others. All right, so we've got our nominal battery width. Now what we have to do is we have to figure out the root sum squared maximum value. Okay, so what this is it's a statistical method that assumes normal distribution, and it says, hey, this is if you're going to do this, this is the range, or this is where you're going to get 99% of the time, because not every part is going to be worst or best case scenario, so it gives you everything. So what we're going to do here to get this is we're going to get the root sum squared of our is going to be the nominal battery width minus the square root of the sum of the tolerances. Okay, so we're going to put this into a formula. So we've got all the information that we've got right here. And even for our example, we've got all the values right here. So this tells you that our answer should be 36.6. All right, so how do we do that? So the first thing that we need to do is I've given you this other column here for our squared tolerances. So what we're going to do is we're going to create and get this part here. So this is what we're working on right now. We're going to get the sum of the tolerances squared. So the first thing that we're going to do is after we've put our data in, we're going to create another formula, equal sign. And what we're going to do with this formula is I'm going to click on the cell that I want to choose. So I'm just going to click on this tolerance cell. Now, again, you're not going to copy this formula over because depending on where you're putting this, your cell locations might be different. So in this case, I'm going to click on cell D3 because it's in the D column and it's the third cell down. And then what we're going to do is I want to get it squared. So I'm going to do shift and the 6 key, which is going to give me the caret symbol. So it's the upward arrow, actually called the caret symbol. So shift and 6, and I want to get it squared. So I'm going to hit 2, and I'm going to hit the enter key. So that has already done the math for us for our tolerance squared. So this is our tolerance squared. Now what I can do is I can write that formula in over and over again, or I can go up to this box, my first cell, and I've got this little drop down over here that'll turn into a plus, and this will copy down. And what I'm going to do is I'm just going to click and hold my left mouse button down and drag that down to copy down for my squared values. And if I click now, you see that it changed. This is D6 squared. This is cell D7 squared. This is cell D8 squared. Okay, so now I've got all of my squared sum values. So what we just did is we solved for this part here. So we just solved for this part here, the sum of tolerances, or the tolerances squared. Now what we need to do is get the sum of them. So I've got, and I've already got this value down here, but I'm going to get this formula out so you can see it again. So I've got down here the sum, so we've got the sum for it. We're going to do it just like we did when we did for this nominal battery width. We're going to hit the equal sign. I'm going to type the word sum in. I'm going to hit the enter key on sum because I'm going to take the sum. I'm going to click and drag a box around what are the values that I need. Close my parentheses. And I'm going to hit the enter key. So there is, I don't want to autofill, so there's my total sum is 1.98. So the sum of my squared tolerance is 1.98. Okay, so our RSS, our root sum squared max width, this is the formula that we need. So to get this formula, what we're going to do is we're going to take the nominal battery width minus the square root of the sum. Okay, so what we are going to do for that formula is we're going to take, and we're going to come back over here to it, and we're going to say, okay, I got to take my nominal battery width, so I'm going to start my formula equals my nominal battery width, so I've already found that, so I'm going to take that cell location, and I'm going to subtract out, and now what I'm going to do is it's the square root. So what I'm going to do is I'm going to do my parentheses because this, I've got to get all of this in here, so I'm going to do in parentheses. And for square root, if I type in S, Q, and I see here it's RT, positive square root of a positive number. So I'm going to do the square root. And what is it that I'm trying to get the square root of? And I'm getting the square root of this sum. So I've already got the sum. So I'm going to click that cell location. I've got to close my parentheses. How many parentheses do I need? 2. I've got 2 I got 2 open, so I got to close 2. So I'm going to close, I'm going to close, and I'm going to hit the enter key. Okay. So this is our RSS max width. Now they've rounded it up, so it's that 36.6. So this would be 36.59. We could actually format this number if we would like to get it to be exactly what it is. So I'm going to go in here, format my number. I'm going to change custom. So I'm going to go in here and I'm going to make myself a custom number format just to show you how to do this. And what I want it to do is I want it to be just uh, one value, and I'm going to hit apply, and there it is. So it's 36.6. So it does the rounding automatically for you. Okay, so if I want to go back, I can compare, and my answer right here is 36.6. So that's exactly what I should have. So it's been a rounded number. So there we figured out our RSS max battery width. Now you're going to do the exact same thing. It's the exact same formula, but instead of doing the width piece of it, you're looking for the height. But the formula is exactly the same. You might change your cell locations up, but essentially for this formula, you're going to take your nominal battery height minus the square root of the sum of all the values that you've got over here for this one. So you're going to do the exact same thing with it for it. So you're getting the practice of it. So now we've got the root sum squared max height. So that means more often than not, 99% of the time, the battery width that's gonna come out is 36.6 millimeters. So that's going to be, if we took all the batteries out of this phone and we started to measure them, they would be, statistically speaking, 99% of them would be 36.6 millimeters is where that battery would be in. Okay. So now what we're going to do is we want to figure out the worst case width. Okay. So the worst case value. So the worst case value is going to be our nominal battery width, which is what our perfect is, minus the sum of our tolerances. Okay, the sum of our tolerances. So what we're going to do here, I'm going to show you this and do a little bit different. So what we're going to do is we're do our worst case battery width. So I'm going to hit my equal sign, start my formula, my nominal battery width, right? And then I can go back here and say, okay, now it's going to be minus all of my tolerances. So I'm going to do minus, and I'm going to do here the sum. I'm going to do the sum, and I'm going to do another parentheses of, and I'm going to do all of my tolerances. So I'm just going to drag and get all of my tolerances, and I'm going to hit my parentheses, and I'm going to hit my enter button. So 34.80 is going to be our tolerances, and we've got 34.8 because we did it. So again, I could, if I'd like to, I could format that cell. So I'm going to format that number, make it a custom number format so that I've got it. I only want it to go to one place value for this, so I'm going to hit apply, and there it is, 34.8. So I've got my formula set up for my formula. So that's going to be our worst case height. Now again, our formula is right here, so this tells us exactly how to do this. But what we're doing is, instead of having to pull out a calculator, we're using our spreadsheet to get that information. So this is going to give us our worst case battery dimension. Okay, so this is, if every other part is as far from the nominal value as possible, the absolute worst case our battery could be is 34.8 millimeters. So that's the absolute worst that we could be. So now what we are looking at is we're going to try to find what is that percent of difference. Okay, so what is that percentage of difference? So what we're going to do for this last piece is we want to see what's the difference. So what we're going to do for that is we're going to start a formula. We're going to hit the equal sign. And I'm just going to give you this one to kind of help out. There's a lot that we're going to do in here. So we're going to need 3 open parentheses. So we're going to do parentheses, parentheses, parentheses. So you know we're going to have 3 that close on the other end. Okay, so we're just going to put this one in. So essentially I'm giving you this one. So to get our worst case difference, what we are going to do is we're going to take our cell C, are going to take our nominal battery width. So we're going to take our nominal battery width, and we are going to subtract that from our maximum width. So we're going to take our nominal battery width from our root sum squared maximum width. And then what we're going to do is we're going to close that parentheses, and we're going to divide it by our nominal battery width. So we're going to divide it by our nominal. So what we're taking is this is what the nominal is supposed to be. We're going to subtract out the max, and we're going to divide it by the nominal battery width. Okay. Then we're going to close that parentheses out, and we're going to turn it into a percentage. So we're going to multiply it by 100. So we're going to do times 100. And then the last thing that we want to do is, if we close this out, right, we're going to close this out, and I'm going to just close this out twice just to kind of show you guys here. So what we're going to do. So what we're going to do is then we're going to multiply it by 0.01 to get us our final 0.01. And we're going to close this parentheses out. And so what do I have here? Oh, times 100. What did I do here? Oh, there it is, times 100. There it is. So let's do this. So when we do this, I'm just going to show you this real fast. So we multiply by 100. So this is going to give us 370. So what we need to do is we need to multiply this last piece by times 0.01. Okay, and this is going to give us our percentage of difference. So we have a total percentage of difference for what we've got for it is 4%. So that's going to give us our difference in our formula. So we take, let's make sure we got our formula right. So we take our nominal battery width, we subtract the max RSS max width, then what we're going to do is divide it by our nominal battery width times 100 times 0.01. And that's going to give us our percentage of difference that we could get from that battery. Okay, so now what you're going to do is you're going to take all of that information, and you're just going to put it through and put it into practice for your steps here. So we've already kind of started for a little bit for you here. So you've got your battery adhesive. Now we can add any of these up, and you're essentially going to just use the information that you've got to do the exact same thing. So in activity 1.2.4, I've taken the picture for you, and you're going to practice creating a tolerance loop to get your nominal battery height, the RSS max height, the worst case height, the percentage could be and still fit into it, right? And so then you're going to do this now, and then you're going to do this again for the battery length. So then we've got our next one is our battery length. Same thing. If you want to extend this out, you can extend this out so you can see this for your battery length. Ultimately, the practice that I'm wanting you to get from this, or the skill, is to take your shoe, and you're going to do all of that we just did, but we're going to do this for your shoe. And in your shoe, I've given you, so this is going to be your multi-view diagram. So this diagram is going to be replaced with your shoe diagram. Okay. But what you're going to do with this one is you're going to look at, now this is not the correct answers, but you're trying to figure out what is the height of this glue layer. Okay. Now the midsole, you've got what the midsole dimension is. You've got the total sole height. This is going to be your negative number. Your total sole height is right here. So this is going to be your negative number. Your outsole height is going to be your value. So this is right here in this, if I use this diagram, 0.350 is my outsole height. If I use this one, now don't use this one because this is the example. Whatever your shoe tread maximum outsole height is, that's the value you're going to put into here. Then you're going to figure in what height can the glue be, or what's the glue going to be. You're solving for the glue. If you know the midsole, the total sole, and your outsole, you're solving for the glue layer. So what you're trying to do is this right here, where we figured this nominal battery width, what I didn't know, this would be your glue. So you're doing the exact same thing with this formula here. So you've got your outsole, midsole, total sole. We're trying to find our glue height. There's our glue height that you're trying to find. you have any questions, please feel free to reach out.